Hello everyone, and welcome to another Leet coding video. So we are continuing our path, our journey, our progress, our battle through the binary search topic. So last time we were actually able to successfully complete one easy, it was an easy binary search problem. Today, it was the first time that I actually was able to legitimately solve a binary search. I've failed multiple other easy ones. So today we are going to try to do another easy one, and then if I'm able to successfully solve this easy, maybe I can try my arrogance out and go to a medium. I don't know. I haven't decided that one yet. But anyways, today we're definitely doing another easy. See if we can get it. I had good luck yesterday. Don't know about today. We'll see about that. And then based off of that, we'll figure out like, okay, how do we move forward with this? So let me minimize myself here, and let's just go to the next easy that is not solved yet. So easy. Okay. This one is locked. Here's this one. Looks like this is the next easy one. Okay, let's go. All right, turn my screen up so I can see. Number 349, intersection of two arrays. Given two integer arrays, nums1 and nums2, return an array of their intersection. Okay. Ooh, and it has a little definition up here. The intersection of two arrays is defined as as the set of elements that are present in both. Okay, so we're given two arrays, two lists, because we're in Python here, and we want to find what do these two lists have in common. Okay, each element in the result must be unique, and you may return the result in any order. Okay. So we have nums1, which is, okay, so I'm noticing that it's not sorted. So it's not like 1, 1, or this one would be 1, 1, 2, 2. And now this one is just 2, 2. So we want to find out what they have in common, which is these 2's here. All of those are in common, but everything needs to be unique. Okay, so that's why we only put 1 in here. Now, obviously, and I need to stop using that word obviously though, because every time I say the word obviously, or the trivial solution, the right, brute force, that's what I should say, the brute force, because whenever I say like obviously we could do it this way, and then I fail to be able to implement it that way, and then I'm just like, okay, darn. But I guess what I'll call it is the brute force method would be to sort both arrays. Okay, so I have nums1 and nums2 sorted, so this would be 1, 1, and then 2, 2, and then this would be 2, 2. Okay, then I have a pointer here and a pointer here, and I look and I see, okay, so 1 is right here and 2 is right here. Are they equal to each other? No. Which one is smaller? Well, it's going to be this one that's smaller, so I'm going to just move my pointer to the next element. And now this one, now remember, let me just write it off. Nums1 is going to equal, and this is this isn't the actual code. I'm just copying this. So we have 1, 1, 2, 2, and then nums2 equals like this, 2, 2. Okay, so here's just sorted. So I come here, I have a pointer here and a pointer here, and I say, are they equal to each other? Do I add to the list, or to my output list, like my answer array? No, they're not equal to each other. Okay, so now I was looking at this one. I say that this one is smaller, right? So I'm going to move to the next one until I get to a number that is either equal. Here's the 2 pointers. Either they're going to be equal or one is going to be smaller, and then I need to move the smaller one to the right until I get to the end of the array. So then I'm going to look here and say, is this one equal? No, it's smaller. Okay, so I'm going to move to here. Now, I say, all right, here we go. They're equal. So now I'm going to say both of these are kind of common. So I am going to add this 2 to the answer list. Then I say, okay, so now I know that here and here, both of these are kind of now invalid because the number 2 is invalid. So I can move the pointer here and I can move the pointer here. Then what I do is I say, okay, are these equal? If they're equal, add to the list. But each time I add, I need to check, like, is it already in there? If it's in there, then I just say, nah, we're not doing that. And so then I would just move to the next element and say, oh, we finished. If either we get to this side or to this side, we know that we have no more elements to add to our answer because there's no more elements to actually put into our list. So I guess this is the brute force method. I'm going to write it out. I'm going to try to see if we can submit it, and then possibly think about optimizations. Obviously, this is in the binary search kind of section, so there should be some binary search trickery that we are able to, some kind of magic that we are able to utilize in this algorithm here. It's not immediately clear, but possibly when we're searching for the next biggest number. Okay, let's think about this a little bit. So first off, let's just write the brute force method. So pointer 1 equals pointer 2 equals 0. Okay, so we're just having pointer 1 and pointer 2 pointing to the 0th index. Okay, so now while, and let's get the length of nums1 and nums2. So length nums1 equals length of nums1. Okay, len nums2 equals length of nums2. All right, so now let's do that while loop. So while pointer 1 is smaller than the length of nums1 and pointer 2 is less than the length of nums2. Okay, so if either of those pointers goes outside the bounds of the array, bam, we need to stop this while loop. We say, all right, we're no longer adding to our answers. So that actually brings up answer is going to be, should I use like a set? Can I just do a set? And then I can just add to the set because I need to check, like, is it in this set each time? Now I'm noticing that it is a list that we return. So we might need to do a list operation. So I'm going to try a set and then see if it accepts it. If not, we'll change some stuff around a little bit. Okay, so now what I can do is I say, okay, Okay, so if there's one more thing that I want to think about. So is this less than or equal to, or is it just less than? Okay, let's think about this a little bit. So pointer 1 is going to be the index, right? So this is going to be 0, 1, 2, 3, 3, and then after we do want to do it on 3, right? But once it gets to 4, we're outside the bounds, and we don't want to look at it, and if we attempt to look at it, we're going to get some kind of indexing like problem. That's a very unspecific term. Like we're going to be trying to access an element outside the bounds of the array. System is going to crash, so we don't want to do that. So this length returns the number of elements. So in here it's going to be 1, 2, 3, 4, right? So this is going to be 4, and we don't want it to run when it gets to 4, the fourth index, right? So this is not going to be equal. It's just going to be less than. Okay, so now let's go. So, what do I want to do? I want to check if the elements are equal to each other. So, if nums1 indexed at pointer 1, and notice I can index here because I've already guaranteed that both pointer 1 and pointer 2 are inside the bounds of their respective arrays. Okay, so if that is equal to nums2 at pointer 2, then what do? We want to, if nums1 pointer 1, okay, not in answer, then answer dot add, I believe add is the keyword for a set, nums1 pointer 1. Okay, so what am I doing? So I am seeing, okay, so cool. We got to the point where we're looking at this number and we're looking at this one. So right now, pointer 1 is 0, 1, 2, and pointer 2 is 0. Now what I say is if nums1 indexed at 2, which is this right here, is equal to nums2 indexed at pointer 2, which is right here, if those values are equal, awesome. What do we want to do? We want to check if this value here, and notice I could have said like nums2 pointer, 2, like that, but it's the exact same, because it's the exact same number, right? The condition is that the numbers are equal, so I just need to choose one of them. So I say, okay, if that number is not already in our set, we just need to add that number to our set, our answer set. Then what do we need to do? Now we know that, all right, well, this number is now invalid because the number 2, which this pointer is pointing to and this pointer is pointing to, is now invalid. So, because we just added it to our set. So we need to move the pointer over to here and over to here, because that's the next possible situation in which we there's a possibility that the numbers are different. Now, do we want to add it? Do we want to do it right here? No, we actually want to do it right here. So we want to increment pointer 1 plus equals 1 and pointer 2 plus equals 1. Now why? Why don't we want to do it right here? Well, the answer is because if, let's say that we get to this point right here, that we've already added the 2 into our answers. And now pointer 1 points here and pointer 2 points here. And let's kind of pretend like there's extra data here. So there's a 3 and there is an, I don't know, 8. Okay, so we're looking here and we're looking here, right? So now, do we want to say like, oh, they're not equal to each other, or sorry, they are equal to each other. There's a 2 here and a 2 here. Cool, so we hit this one. Now we come here and say, oh, it's already in answer, so I don't append it. And then I'm just going to, like if it was like this, what would happen is this entire branch would not hit, and we would just stay at this index. That's not what we want. If we decide to add it, then we add it and then move our indices. If we decide that we don't want to add it, we don't add it, but we still have to move our indices. So that's why it's out there. Okay, so now what is the other option? So if they're not equal to each other, else, now we need to look for the lower pointer, not the actual pointer value, not the index. We need to say like, okay, well, if this one, let's say that we're looking here at this 1 and we're looking here at this 2, right? The index is 0 here and the index is 1 here. So I want to say, which one do I want to increment? Which pointer do I want to increment? Well, because the lists are sorted, and I just realized that I actually did not sort the lists. Okay, so nums1 dot, what was it, sorted? I don't like how they're how it's not glowing right there. Nums2 dot sort. It should be glowing. I think it's, what is the correct keyword? Sorted, right? Sorted. Okay, that's glowing. Nums1. And does this operation happen in place? So if an operation happens in place, it means that it changes the actual array. Okay, so sorted dot nums2. Now, just for my like sanity, can I do nums1 dot sorted? Okay, so it doesn't. There's no like glowing keyword. It might work. I don't know. So let's just assume for right now that nums1 and nums2 are actually sorted like this, and that this operation works as I'm expecting. If it's not, then we're going to have to figure out, okay, what's the correct syntax in Python for doing a sort? I mean, realistically, that's like a 10-second Google search. But anyways, let's just assume that it is. Our purpose right now is to actually figure out the algorithm. So we said that we were looking at this 1 and this 2. Now, because our lists are sorted, both of them, is there any possibility that this 1 can actually be added if we're already looking at a 2? Well, no, because 2 is guaranteed not to be in this list here. 2 is bigger than 1. So we say, okay, I don't want to look at this 1 anymore. I just want to go to the next element because I know that it's going to be bigger, right? So now I'm going to be looking at this bigger element. So what I need to do is check which one is bigger and then move, because we know that they're not equal. So one of them has to be bigger. Okay, so if nums1 evaluated at pointer 1 is bigger than nums2 evaluated at pointer 2, then what do we want to do? We want to, so in this case, that means num2 is smaller, so we want to increment the pointer 2 plus equals 1. Else, pointer 1 needs to be incremented, right? So if if nums2, the element in nums2 is smaller, we need to increment to the next indice in nums2. Otherwise, it means that nums1 is the smaller element, and we need to increment the pointer in nums1. Okay, so now this is going to keep going until one of these pointers, or both, go outside the bounds of the array, at which point we have all of the elements that are the same. So we can just return, and now here we go, answer, but this is a set, so I don't know if it is going to complain at me. Let's press that submit button, figure out if there's like syntactical errors, if this right here is correct, if that thing that it's a set, I wanted a list, and you see up here like I'm in the way. Right here, it's a list of integers. It might not like that it's a set, so we're gonna see about that. So let's just press that submit, and then we also need to do our optimizations. See, error type 2 is not valid. Expected return type. Yeah, see, it didn't like this. It didn't like it. So what do we need to do? Is there like an easy way to turn a list into a set? Or do I actually need to iterate through all the values in the set? Let's see, answer set. Okay. And then what I'm going to do is like answer equals, and then a empty list. Then when we come here, I'm just going to for element in answer set, answer dot append element. Okay, so I'm just going to go through each of the elements in the set and then append it to this list. So let's see if it likes that one. I didn't like that. Okay, answer.add. Why does it list? Oh, because answer set. Add is for sets, and append is for lists. So it didn't like that we were trying to add to a set. Wrong answer. Okay, well, at least we got expected. Okay, so we just have 9. You know, is this, I'm just gonna print, and am I working in I think Python 3 you can do the F right here. I don't like how like Python 3 and then the other one, like just regular Python, it has what's that? Mr. Coding would love this this one right here. Oh, what version of Python are you operating on? 2.7 18. Anyways, just never mind if you don't know. Anyways. which 3.11. Here we go. Now I know how to answer his question. Okay. But anyways, I if I'm doing Python 2 versus Python 3, this syntax is always cattywampus, and you have to figure out like, okay, I think it's like something like this, and then dot format, and then you have to add your arguments, like whatever. right here. But I think Python 3 does it the chill way of you can just do like F and then here and then typing something. So adding, and then you can just go like this. Nums1 indexed at pointer 1 to list. I think you can do it like this in Python 3. So let's figure out, because I think it should add 4 to it. So that's why I'm like, what's going on? Okay, so adding 9 to list. So it is not. It's for some reason skipping 4. So let's walk through this test case and figure out why it would not be adding 4. So pointer 1 is, so the list is going to be sorted. Oh, perhaps we didn't actually, let's print nums1 and nums2, because I'm suspecting right now that we're not sorted, because look at this. So if I come here, I see like 4 and 4, okay? But if we don't actually sort it, we're going to see a 4 here and a 9 here, which is going to be at 0. So I see that 9 is bigger, okay? So that means that I'm going to move this one over by 1. And now it's going to be 9, 9. And I say, okay, great, let's add them to the list. And now we have adding 9 to the list. And then I move my indices over by 1. So I have 4 and 5. Now, notice, 4 and 4, they're both in the list, but I moved my indice over here. So of course they're never going to actually hit each other, because the numbers are not sorted. Our assumption was wrong, right? We were assuming that this worked. So I'm just going to print, okay, nums1, because at this point, if this was an in-place operation, it should have worked. So let's print nums1 and see if it is sorted. Nums1 is 495, so it is not sorted. Okay, so there's some problem here. What if I just did like nums1 dot sorted, nums2 dot sorted? I know that there's, if this doesn't work, this is something that there's no value in, there's no value in actually going and trying to guess syntax. That's not something that is important at all. That's a question. So, how can I sort a list in Python? Okay. Okay. So sort. Okay, so it's just the list and then sort, so not sorted. Right? That's what it said. No, dot sort. Okay. So let's see about that. Hey, here we go. Okay, cool. So we got the algorithm correct, but I'm not feeling too hot about the efficiency of this, because right now what we're doing is O of n. Now, my question though is actually when I'm doing this sort right here, that's actually a good question for GPT as well. What is the time complexity of dot sort? So what is the time complexity of numbers dot sort? Okay, let's figure that out. And let's assume that this is like, I don't know, in or log of n or something like that. It has some good time complexity. They did some fancy tricks or something like that. Okay. This part right here is the part that I implemented, and this is the part that I implemented. So now, what is the time complexity of here? This, we have to iterate through each of the elements in the list 1 and 2. So it is going to be O of n, where n is the number of elements in... Okay, would it be both arrays? Or would it be the largest array? So in the worst... Okay, I need to think about that. Because if I have this right here, let's say that this is like 1,000,000 elements long. So like 3, 3, and this is sorted though. So 3, 3, 4, 4, 4, 4, 4, 4, 4, 4, like this, right? Like 44. Okay, whatever. And now, let's say that this was just like enormously long. Okay, I would come here and say 2, and then 8, or 2, 2, come here, then come here, then come here, and now see the 2 and 2. Then I would move here and move here, and then I would move here, 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 and again, I said that this was 1,000,000. There's 1,000,000 4s in here, right? So I would have to go through all 1,000,000 4s right here before I ever hit this 8. And so even though this one is just 4 elements or 3 elements long, I need to go through all 1,000,000 of them before I can say, hey, guess what? We're at the end of this array, and we don't need to keep looking anymore. So I do not like the time complexity. The algorithm works, but it's not great. So let's should have finished up what it was, the time complexity. So best case for sorting is O of n. Average case n log n. Space complexity is O of n. So here's the thing though. If these two are n log n, and even the best case scenario is O of n. Okay, both of these are O of n. This has a complexity of O of n, where n is the longest element, right? So it doesn't matter, right? Like if this is a larger time complexity, let's say that this was, let's say something ridiculous. It was in factorial, right? These two were in factorial, and we're doing it on both list 1 and list 2, which means that the larger list is going to be run. So this time complexity is already bigger than this time complexity. So therefore, this is okay, actually. And same thing with this. This one necessarily is, these are only the elements that were common between both lists. Therefore, the worst case scenario is it is all elements in, like, every element in both lists are exactly equal and unique. So it's just like 1, 1, 1, 1. So it is O of n right here. So this is okay as well. So actually, the time complexity should be okay. I want to ask GPT about that. So I'm just going to come here and paste it. So here is my answer to this right here. can you, is my solution optimal? Okay. Let's see what it has to say. Okay, your current approach sorts both arrays and uses 2 pointers to find the intersection. The result is stored in a set to ensure uniqueness, which is then converted to a list before returning. Yep. So sorting both arrays incurs a time complexity of in log n for nums1 and m log m for nums2. And now this one, the time complexity is O of n plus m. So it is it's a time complexity of both elements. I thought it would be just the larger one because we're stopping at when either one gets to the end, but I guess in the worst case scenario, it's both of the elements. Okay, sure. So the overall time complexity is n log n plus m log m, which is, I think, what I was yeah, because we're sorting here and we are sorting here, so we're adding those time complexities, which is exactly what I was saying when I said because this time complexity is the larger one, this is completely fine. All of these are completely fine. Caveat, is there a way to do it without sorting? Because if we don't do these two operations, we potentially could limit our time complexity, make it smaller. Okay, so auxiliary space, so space complexity. You store unique intersections in a set, which takes the minimum of n or m. So that makes sense, right? Like, we have two lists, number 1 and number 2. I'm not going to call it n and m because that's going to be way too confusing. So number 1 and number 2. So we need to figure out how many elements are in number 1 or number 2. Let's say number 1 is smaller. There's less elements in nums1. Okay, so what is the largest space that I can take up in my set? Well, it is the number of elements within the smallest set, because if I only, for example, if I only have something like this, right, like let's say nums1, let's go like this, where nums1 only has one element, and then this one has like 1 1 1 1 1 1 2 2 8, and then 9 9 9 9 9, right? Okay, we come here, and then we come here. We only add this one time. We only add the number 1 one time. So the worst case scenario is how many elements are in the smallest list. So that means here, right there. Okay, while your solution is already quite efficient, here's an alternative approach using hash sets that operates in linear time. Ooh, I like that. Linear time. Although, wasn't this linear as well? Like, it's just because that's sorted. Just because the sorted has me all messed up. Okay, so using hash sets. So this solution uses 2 sets to find the intersection. So traverse num1 and add each element to a set. Traverse nums2 and check if each element is in the set. If yes, add it to the result. So, ooh, I like that. Oh, and you can, hey, look at that. That's nice. I don't need to be doing any of this weird stuff here. I can just replace this. I could do it like this. Like, watch this. answer set, so it's a set. Nah, man, I'm making you into a list. How do you like that? Submit. We're not even dealing with that with this answer set. Not in. Wait, hold on. That shouldn't have been accepted. Not in answer. Yo, what? That should not have been accepted. Answer is an empty array right here. And I never touch answer. I know why it's accepted. Because I'm adding to a set right here. And a set is unique. So when I add an element here to my set, it just ignores it if it is duplicate. And then when I come here, I have no duplicates because a set doesn't have duplicates, and then I convert it to a list, and so I just take all of the unique elements. So I think I could have like done something like this. Let's see about, and I don't need this print anymore. Okay, I think I could have done something like this where I didn't even check if it's in a set. I just simply add to my set. So answer set dot add and then nums1 and pointer 1, kind of like this, and this should also work, I think. Yeah, see, it worked. Okay, cool. So that's why. And okay, had me confused there. I was like, why on earth was that working? But now it kind of makes sense. It's not what I was trying to do. The correct way, obviously, is, I mean, I guess it doesn't even matter, but I should have said like set right there. And the reason I said that it didn't even matter is because I'm either doing the check or I'm adding it to the set anyways, and then it just gets rejected. So it's like, does it really matter? I don't think it does. So let's have some fun, okay? And let's do it the way that they were talking about. Let's try it out. So what am I going to do? It said that I'm going to use like a hash, right? Hash. Let's see about there. So I'm using a set for nums1, and then I'm iterating through nums2. Okay. So, okay. Set 1 is a set. Now, do we want to add all of nums1? I think we do, because I want to check like I'm going to be iterating through each of the numbers in nums2. I'm going to be iterating through each of these elements in nums2, and I'm going to say, is it in the set? And that's an easy operation to check. I think it's O of 1. I think it's an O of 1 time operation. So it's instantaneously, essentially. So I'm going to say, all right, I'm at nums2. I wish I didn't delete that. Like nums1 is equal to whatever, like 1, 4, 3, 2, 6, 7, and notice it is not sorted. Now nums2 is equal to 2, 4, 6, 99, 0, 8. Okay, something like this. Alright, so now I want to turn this into a set where let's say that let's add some duplicates in here. So we have 4 and 4 and 4 and 4 and 4. All right, so this is going to kind of be condensed, and we're going to ignore all of those duplicates. And now what I want to do is I want to go through each of these. I'm going to go to 2 and say, okay, is 2 in my set? And this is a set. And so checking is O of 1. And I say, hey, here it is. I said 2. Okay, cool. So then I go to the next element in my nums, 2. And I say, is 4 in my set? Yes, it is. So I add 4 to my answer. And let's do answer is going to be equal to an empty set. Okay, just an empty set, and we're going to add elements to it each time we find an element in nums2 that is present in the set which represents nums1. So let's do that. So while pointer 2 is less than length of nums2, okay, and let's create that variable. So length nums2 equals length of nums2. All right, so what do we want to do? We want to, if, and we're checking nums2, so nums2 evaluated at pointer 2 in set 1, then we want to append it or add it to the set. So answer dot add nums2 evaluated at pointer 2. So what does this mean? This means that nums2, the number that we are currently looking at, is found to be within the set representing this array, or this nums1. Okay. Then we want to add it to our answer. And notice this is a set right here. So we can add the same element multiple times to this set, and it's not going to cause us a problem because sets are unique. That's why kind of when I saw that error, I was so confused about it. But you are allowed to add multiple elements of the same value to a set. It just ignores it. It says, okay, I already have that in my set. I'm not going to acknowledge you. So we can just say, like, if it is found to be in both nums1 and nums2, add it to our answer set. And then at the very end, we change that set from a set to a list. Okay, so if it is in the set, then we add it, and then we want to move to the next element in nums2, so pointer 2 plus equals 1, and we are going to be starting at pointer 2 is going to be equal to 0. So we start at the 0th index. Okay, so now we return list. Ooh, I like this. I love Python. I love Python so much. I cannot tell you how much I like Python. Like, again, back to that Mr. Coding guy. Like, what's your favorite feature about Python? I don't have a favorite feature about Python. I just like it. It feels good. That's my favorite feature about Python. I like it feels free. When I'm coding in C, that's what I do for my job. I'm more of, I don't know how to describe my job. My title is software engineer, but I'm actually not a software engineer. I'm a firmware engineer kind of like an embedded systems engineer. So I'm writing software in C, and then also doing like troubleshooting on the actual physical hardware. So I do both electrical engineering and software. Like that's not really even software engineering. That's more like firmware engineering, right? So I do hardware and firmware engineering. So I'm doing C, right? I, each language has like a different feeling. Whenever you're writing in C or C++ or Java, right? It feels oppressive. It feels heavy. It feels all of that. Python feels light, and you're just like that. Like it's a feeling. That's what I like about Python. Okay. Anyways, list of what are we doing? Answer like this, and we are submitting that, and we're going to get an accepted, hopefully. And it was accepted. Hey, there we go. Okay, awesome. Well, I think that's the video. All right. Well, thank you everyone for watching this video. I hope you enjoyed it. If you did, consider subscribing. That would be awesome. Recently I've gotten a lot of new subscribers, so thank you to everyone who subscribed. That is awesome. Thank you, thank you, thank you. So, anyways, yeah, I will be back tomorrow with another Leetcoding video. And I hope you guys have a wonderful day. My name is Timothy Lee Grant, and see you tomorrow.